Good to go. Good. Good evening, everyone. I was going to say, guys, down the back, if you want to take a seat, we're going to get started soon. Welcome. This is AI for Developers. We are the AI User Group. For those of you who aren't familiar with us, we are a community of professionals who are figuring out how to use AI in our day-to-day. What are best practices? How can we integrate it into our workflows? And really, how do we make the most out of it? So we have a really good lineup today, and just a couple of announcements from me before we get started. Also want to say hi to our LinkedIn Live audience. So great to have people join us from all over the world. Today we have a co-organizer, N8N, who have kindly sponsored this segment. You're going to have a little note from Max in just a moment. And we also have Neo4j in with us as well. So I'll play you a little video in just a second, but just on the agenda for today, first we'll be hearing from Kyle, then we'll be hearing from Anushrut, and then from Justin. We will then have a little quick moment of community announcements. So like a 5-minute segment, you can come up here, make an announcement, maybe there's a job opening or something you'd like to announce, and then we'll move into networking and pizza. Doors will close at about 10 to 9, so I'll be coming around and wrapping up networking with you guys. And if anybody has a thought about it, maybe they might like to speak. We have openings. Actually, next year, we're really quite booked out, but if you're interested in speaking, come speak to me. I will leave my email at the end. But just to kick off, I want to play you a little video from N8N.
Hi, I'm Max, developer advocate at N8N, the automation platform for technical teams. In this example, you're seeing I've got some nodes on my canvas. Each node executes and passes its data along to the next node. But what I'd really like to show you is our new advanced AI functionality. In this example, I've created an AI assistant that helps me interact with my Google Calendar and lets other folks book an appointment with me. So how this works in a nutshell is this agent has various dependencies that it needs. It has the LLM itself, it has some memory so it can handle multiple conversations at once or multiple threads in the conversation. And then it has various tools to understand how to fetch availability in my calendar and to book that appointment. So let's do a quick example demo of this, and then we'll see how it works. So let's see when Max is available next Tuesday. So what my AI agent is doing now is it's understanding them asking for availability, and so it's using the tool to fetch my availability. The agent knows when today is, so it knows when next Tuesday is, and here now it's listed the various slots that are available. Let's book something for 4:30 p.m. Okay. And so my agent is still running at this moment. Great. So the agent, before it makes this request, it understands that it needs my full name and email to complete the request. And so let me specify that. So now that the agent knows that it has all the information that it needs to make the call, it can book the appointment on my behalf. Great, we can see we've got a confirmation here. If I check in my calendar, we see at 4:30 p.m. we've booked that appointment. Now, let's see what's happening under the hood. So my chat trigger here is collecting the responses from myself and sending it along to the agent. This is an arbitrary step, right? So this could be a webhook trigger, this could be your own custom trigger that you've coded. That really can be anything that you'd like. It pipes the message into the agent, which then interacts with its various tools. In the agent itself, I have a system message. I'm letting it know that what its task is, and I'm also giving it what today's date is, and that appointments are also 30 minutes. I myself am not a prompting expert and wrote this rather quickly, so you don't have to be an expert to start getting value from this. And then the magic really happens in these HTTP request tools. So each one of these tools allows my agent to consume an API endpoint and understand how it works. So we've got the Get Calendar Availability tool, and we've got the Book Appointment tool. So setting one of these up can literally take a minute or two. As you can see, I've described very simply when it should use this tool, call this tool to book an appointment in the calendar. I then define the endpoint that it should consume. I define the credential to use if necessary. Since we have Google Calendar credentials in n8n, I'm using a predefined credential type, but I could also use a generic one if it's something like a proprietary system that you're connecting with. And then from there, I'm essentially defining the payload to send in my body. And as you can see here, I've got some static parameters. These are the things that I don't want my LLM to manipulate. And then I have placeholders for the things that I do want it to manipulate. And as you can see, I can blend static text with these dynamic parameters that I'd like the LLM to control, or my agent to control rather. And then if I want to, for added control, I can, for these placeholders that I've defined, I can add some more definition on how the AI should interact with those parameters. So there can be a description, and I could even define the expected data type of that. So again, I'm constraining what my agent does, so we have more predictable outcomes when we ship this to production. So from here, I could add more tools, of course, depending on what I need my agent to do. There's various off-the-shelf tools to understand the world or perform math, etc. I can interact with an arbitrary API endpoint. I could write a tool in code, and I can even call other n8n workflows. So this workflow that you saw over here could be consumed by my agent. We have hundreds of native integrations, so it's a really fast way to get your agent interacting with the tools and services where you have valuable information that your users, customers, etc. might want to interact with. I'm Max from n8n. We've just scratched the surface in this demo, but make sure to check us out.
Great, brilliant. Thank you so much, guys. I was going to say we are going to get started with our speaker next. So I'm going to let Kyle come up. Welcome to the stage. And Kyle's going to be speaking about, do you even need fine-tuning? Thanks. Okay, over to you.
All right.
Once your screen's on. Just a second. All good.
Okay. I think we're still waiting on the microphone. Sound check. Sound check. Ooh, got so much power now. Okay. Hey, everybody. My name is Kyle Corbett. I work on a company called OpenPipe. Excited to be talking to all of you. This is a little bit weird. I don't know if I've ever given a talk like this sitting, but I guess for camera reasons I am. So I'll just be very dynamic with my hands, maybe. I don't know. We'll see. Anyway, we're going to be talking about fine-tuning here. Specifically, we're going to be talking about whether you should be doing fine-tuning, and we'll also define what fine-tuning is. If that's unclear to anyone in the audience, don't be worried about that. I am going to start by sharing my biases. I happen to work for a company called OpenPipe that explicitly is about fine-tuning. So there will be, I have an opinion that fine-tuning is at least sometimes useful. That said, it's also important to say that most of the people who come and ask us about whether we should be fine-tuning our models versus just staying with prompting, I actually tell, you know what, at the stage and with the problems you have right now, I would not recommend you fine-tune. So the answer to this is not going to be, yes, you always need fine-tuning, as you'll see as we get into it. But let's talk about when we do. There are three main components that I would like to cover today. The first one is why. Actually, you know what? I'm going to do an audible here. We're going to add an extra component, 0. 0 is what is fine-tuning. I want to, just a raise of hands, how many people kind of would be able to describe at a very high level what fine-tuning is in the context of machine learning or LLMs? Okay, cool. So it's looking like probably less than half of the audience here, which is great. So we definitely are going to add a step 0 here, which is what is fine-tuning. Fine-tuning conceptually is really simple. Probably everyone knows that these machine learning models are trained by being exposed to vast amounts of data on the internet, sometimes from human feedback, lots of different sources. Fine-tuning is basically just a continuation of that process, where instead of continuing to train this model on vast amounts of random data that's not related to your problem, you gather specific data that is relevant to the task that you or your company, whatever you're using this model for, is trying to do, and you train the model on that specific set of data. That's what fine-tuning is. It's you're actually changing the weights of the model to understand your problem better. Okay, so that is what fine tuning is. The next three parts of this talk are going to be why would you do it? Like, prompting actually works really, really well. So is it even necessary? Like, do you need a model that is specific to your task? The second question is, when is the right time to do it? So if we know that under some circumstances it's useful, like when do those circumstances apply to me? When should we be doing it? And then finally, we'll get into the brass tacks of how you actually go about this. So when that time comes, or for many of you, you may actually be there, you understand what the steps you need to take are. Okay, let's start with the first point there, which is why. Why do I care about fine-tuning? Why is this something that I would spend my time on? All right, I'm going to ask for another show of hands here. Who has seen a graph something like this at some point? Basically where you're kind of measuring a model cost versus the quality or some metric of like how strong that model is. Raise your hands high if you've seen a graph like this sometime before. Okay, similar, maybe there's a lot of overlap I'm feeling in the distribution of people who knew about fine-tuning and people who'd seen this graph. Maybe about half of folks had as well. So this is pretty standard. This is basically, this is one way you can decide what model you should use for your task. You can look and say, okay, there's different tokens per dollar up here, so maybe you have a hard limit based on your unit economics or how much budget you have to spend on this for how much you can, like how smart a model you can do, and then that'll kind of dictate which model you choose. By the way, this is one way of graphing these. There's other dimensions you can graph these models on as well. A very common one that is relevant for many use cases where you have interactive components is you can measure the output quality versus latency as well. And so if you're doing anything with, say, voice chat, or even just like normal chat, or you're doing a bunch of calls in a row in sort of like an agentic framework or something, and the user's sitting there waiting for you to do all these calls, you're going to start caring a lot about latency. And that's something that's also very correlated actually with model cost, in the sense that cheaper models are usually lower latency because both of those are associated with model size. The smaller your model is, the faster it'll be and the cheaper it'll be. So moving to smaller models does have some substantial advantages. The disadvantage, of course, as we're seeing in the other axis, is generally as you get to the smaller models, you're getting less intelligence. You're getting just a model that's not as good on kind of the quality. Okay, so this is a very general trade-off, and we can actually draw on top of this chart, we can draw this nice Pareto frontier, which is, okay, for a given amount of money I can spend, what is the best model, right? So if I'm doing something at huge scale, I'm scraping the whole internet, well, maybe I'm looking down at this tail end of the distribution where we've got Gemini 1.5 Flash, which is super cheap to run, but not that strong. But if I'm doing super high volume, maybe I need that. On the other hand, if I'm doing a very low volume use case, then maybe I want to just get the best quality model I possibly can, and we're going to be at the other end of this, way up with Claude 3.5 Sonnet, which is potentially the strongest model that's available publicly today. Okay, so that's kind of like very, very intuitive. That's how you make that decision. Okay, we're going to take an aside. I promise I'm going to tie this back to fine-tuning in just 1 second, but we need to kind of make another observation here. So what we're seeing right here is this is actually some research that members of our team at OpenPy put out some time ago. It's a very simple thing. This is just a definition of a prompt chain that we have found actually can improve model performance significantly. This actually is not unique to us either. We basically were just grabbing kind of like things that were known in the ecosystem and quantifying the output. But this is just an example of a basic prompt chain. Okay. Why would you do a prompt chain like this? Actually, let me talk through what the prompt chain is in case that's not clear. First of all, you're just going to call the LLM the way you would normally. You're going to ask it to generate several different responses. You will then kind of call your LLM again and say, hey, look at these outputs. Tell me what's good or bad about them. And then finally synthesize them into a final response. Okay, pretty simple. Again, this is actually a pattern that a lot of folks use. You'll see it implemented in frameworks like LangChain. Why are we talking about this? Well, the reason we're talking about this is because going through even a very simple chain like this can actually help your output quality significantly because for a number of reasons. One reason is that these models are not necessarily deterministic. They can make mistakes in like an inconsistent way. So we've got these three responses here. If maybe like one of them goes off the rails, then you're going to notice that, then kind of this prompt 2 will notice that and kind of account for it. Another reason is just giving it more time to think, giving it more time to reason over the thing can help it improve its quality. So in practice, what we find is that this does, on average, help performance. Okay, there's some downsides though here. It's slower because remember we're calling our LLM 3 different times with 3 different pieces of information compared to just like a single call. It's more expensive. Again, those 3 calls, it's going to cost at least 3 times as much. And of course, on the other hand, on the positive side, you are on average going to get higher quality completions. And we actually, on our team, we validated this. We actually have the top entry right now on both the Alpaca Eval and Chatbot Arena Hard Auto benchmarks right now using literally exactly this technique. So the quality is there, but again, it's slow and expensive. Okay, so what does this do? Let's say we're bringing that technique into this output quality versus tokens per dollar thing. Well, we can actually add that prompt chain we were just talking about as sort of its own category here. And I'll put that right there, okay? So we're calling that mixture of agents. That's just the name of this specific prompt chain. And this mixture of agents approach, let's look at kind of where this is on the graph, right? And again, this is, we'll see exactly these trade-offs. So it's way over here on the left. That means it's way more expensive than anything else we've got here. And it's also slower than anything else because, again, that's correlated. On the other hand, it is the highest quality outputs we can get relative to just calling these prompt models, these base models. Okay, so this is interesting, right? This is, what the cool kids are calling like, increasing inference time compute. Basically like doing more calls at the at inference time to get higher quality. That's a really useful tool to have. Of course, it does come with those downsides we said, which is this is now much more expensive and slower. And we've actually found for a lot of use cases, this gets too expensive and too slow. I mean, have it take 3 times as long, having it cost 3 times as much, puts this out of the range of many actual like real production use cases. But we're finally we're getting to the climax here. I hope everyone's excited because I'm about to show something that's like really magical. Okay? Okay, it's not going to look magical. I will explain why it is magical. All right, look. Is everyone saying ooh and ah? Okay, thank you. Yes. Fine, I will explain why this is magical. Okay, so what we have found is that there's a really nice pattern you can do, which is you start with this mixture of agents approach. Okay, you get the highest quality completions you can. And maybe that's too slow, maybe that's too expensive to use in production, that's fine. You can do this kind of offline, you can use one of these other models in production and then use this mixture of agents to sort of like reprocess your data later. Once you've done that, if you take the outputs, those very high quality outputs you got, and you just fine tune one of these other, say these open source or even there's closed source models, either way it works, models on those very high quality outputs, you end up with a model that for your specific task, and this is very important, you can't just do this like generally with like any set of outputs. It has to be like very specific to your task. But what we find is if you do this with inputs very specific to your task, you can actually recover and retain a large fraction of the benefits you got from that very slow, very expensive mixture of agents with a much smaller, much faster, much cheaper model. Through fine-tuning. So concretely what you're doing here, you're taking those outputs, and then you are training this smaller model on those outputs that were specific to your problem. And what you get out of that is you get a new version of that model, which is much better. Another way of looking at this is kind of starting from the base model. So you can see each of these fine-tuned models that's showing up in green here comes from one of these other models that we already had on the chart, right? So we've got Llama 3.170B. By the way, this is real data. Like these are plotted from actual evals that we ran internally, averaged across 4 different customer tasks with fine tuning on their specific data sets. So this is not just an illustration. This is actually like typical results that we see. Basically, each of these base models, once it's been fine tuned on the task, the performance improves drastically on that specific task. So this is kind of the whole trick. This is the reason you would do fine-tuning, is because let's say that you can only pay, like this much per token because you're doing a high-volume task, or you have high latency, or you need low latency. Well, by adopting fine-tuning, you can keep your costs way down here and push your quality way up here, okay? That's the trick. That's the reason you would want to do fine-tuning, is because for a much lower cost, you can have a model that works much better on your task. And so what does this do to our Pareto frontier we have right here of the cost versus quality trade-off? Well, if we incorporate those, we can see, boom, it just moves way further out. So wherever you want to be on that frontier, however much you can spend, however much latency you can afford, you're going to get a better result if you have a fine-tuned model that is specific to your task than if you're just using a general prompted model that has to be good at your task and a million other people's tasks as well. That's the whole thing. That's the reason you would do fine-tuning. Okay, so super exciting. Look, we pushed out the Pareto frontier. So let me just, it's so satisfying. Okay, we pushed it out. Awesome, no trade-offs. We should all be doing fine-tuning, right? Okay, unfortunately not. There are some trade-offs. There are reasons why it doesn't make sense to just automatically do this immediately, and I want to talk through that right now. The main reason is because this process, it takes time. Okay, it's going to take engineering effort. You have to put together your data set. You have to basically spend the time to figure out how to fine-tune the model, and then you have to deploy your own specific model, custom model, which is not the same one everyone else is using. There are challenges involved in just operationally in doing that. And then the second very important one is it decreases your flexibility. So these models, once you fine-tune it on your specific task, on whatever it is you're trying to do, they're going to be very good at that. But it's actually going to be worse, or at least have much less improvement, and in many cases actually worse, on a bunch of other tasks. So your model becomes less flexible. It's very good at your thing, very bad or relatively bad at everything else. And this also leads to operational challenges because, say you've got a bunch of, let's say you're doing, information extraction from documents. Well, now if a customer comes to you and they have a new document type that you haven't seen before that wasn't in your fine-tuning data, you may not do as good a job on that as you would have, without the fine-tuning. So you have to actually monitor for that. You have to make sure that the inputs you're getting actually do match the same data, or the shape, the kind of data, the class of data that you had when you were actually training. So those are the two trade-offs. Those are the reasons you wouldn't want to do that. And I want to get a little bit more concrete with that on kind of how you can think through those trade-offs and make that decision. So given those trade-offs, there's obviously you don't want to do this immediately. Because when you're very early on, when you're developing either a new product or a new, or you're developing a new feature on your product, you're probably iterating really fast, and this flexibility thing right here is at a very high premium, and time is probably at a high premium as well if you're trying to get to market quickly. So it doesn't make sense to do it immediately. When does it make sense? When should you invest the time in doing this? The answer is when your prompted workflow runs into one of three barriers that you cannot fix with prompting. And those three barriers that we see, and this is in rough order of how commonly we see them, is first, if it's too unreliable. If you find that maybe 85, 88% of the time your model is doing what you want it to do, but then, that last 12, 15% of the time it's not, and you've tried prompting techniques, you've tried training, basically all the stuff, few shot examples, and it's just not quite able to get there all the time, fine-tuning can be a huge benefit. It can get you from that, say, 85% up to maybe a 98, 99% accuracy, and that can make a big difference in your user experience for your users. The next one is too expensive. So as we saw, you can move from a Claude 3.5 Sonnet down to a Llama 3.1 AP, which is 1.5 orders of magnitude cheaper, with actually similar or superior performance. And for many use cases, that can be really important. Or too slow. Again, moving to those smaller models gets your latency down. So if you don't run into these issues, if you're totally happy with quality and the cost is not, your unit costs don't matter that much, and latency is fine, you probably shouldn't fine-tune, because these are the problems it helps with, and if you don't have the problems, you shouldn't solve it. But if you do run into them, then that's when it makes a lot of sense. What we often find is this makes sense as you're starting to scale, as you're getting more, you're going to have more volume, you are going to have more usage, unreliability is going to be more annoying because it'll be users you don't know, and you're just going to have to be spending more money. And so often it's when you're actually scaling. That's when we see these issues start to becoming more acute, very commonly. Okay, so I don't have that many minutes left. We're going to do a lightning round of how do we actually do this, And what I'm hoping you come out of this part with is this is actually not that hard. Okay, we've had customers successfully deploy fine-tuned models with less than an hour of engineering time, literally going from GPT-4 to having their own fine-tuned model deployed. So hopefully that's where we come out of here. Okay, there's 4 steps here. You've got to prepare the data, you've got to train your model, you have to do evaluations, and finally you have to deploy your model somewhere. All right, these are the 4 steps. We're going to go through them. Does anyone here have experience with sort of traditional pre-LLM machine learning? I'm just curious. I realize that's not the main audience. Okay, we do actually have a larger number than I expected. Okay, awesome. Well then, those of you that do have that experience, if you've gone through this process before, are going to be very familiar with this nice acronym I've come up with to explain these steps. This was actually a really hard process. Like, this is, when you hear people say don't fine tune, it's often because they have that PTSD from traditional machine learning, where this would typically take, at a minimum, weeks, very often months, to go through the process. Typically, it's actually the data preparation and then evaluation that take a lot of time. We're going to talk through how to make that much faster and why this is different now. Okay, preparing data, extremely simple now. The reason why, you can start with those prompted models, and you can just start gathering data from there. If you can get one of those mixture of agents flows working, for example, you can deploy that in production, just capture all the requests and responses and train on that, and you can be in really good shape. Okay. Now, sometimes, even those mixture of agents outputs are not strong enough. There's a lot of, basically, sometimes you do have to do a little bit of data management. There's lots of tools out there. There's open source tools you can use to basically quickly review your data set. And you don't need huge data sets for this to work, by the way. In sort of this LLM regime era, a few hundred examples is often plenty. And so having a human manually review those is not insurmountable. You can also use LLMs, different types of filtering. I do find that third parties like Scale AI are probably not a good fit at this stage for most people, just because LLMs are able to replicate them. But internal human review can often still be really valuable because you have unique insights into what you're trying to accomplish. Okay, next you need to train the model. This part is relatively simple for anyone who has a strong background in software engineering. Like if you can, if you can even prompt a model, you probably actually, and you have that last step, the data set, you can train it. We make this really easy at OpenPipe. There's other hosted providers like Together, Fireworks, Anyscale. There's open source libraries. In fact, of these 3, I would really highlight Unsloth as doing a great job on the kind of being approachable and user education point of view. They've got great notebooks that you can see just how to do it. They have great code examples. So this process is actually not that hard. There's good guides out there. You can find them on Medium, other places. And of course, the hosted providers make it very easy as well. And then you need to evaluate. I'm running a little low on time, so I'm going to speed through this a little bit. This could be like a whole talk. This could be a whole conference just on evaluations. The way I think about it, you need 2 kinds of evaluations. You want some kind of inner loop evaluation that you can run really fast. We find using an LLM itself to judge the outputs of your fine-tuned model is one example of this. If you're doing, say, classification or information extraction, sometimes you can have a golden data set that you compare to. And then you also want an outer loop of evaluations. And this is okay, what is the actual business impact I am trying to use this model for? What is the actual higher level goal? How do I measure if it's doing that or not? That's going to be very, very specific, of course, to your task, and typically requires actually running this in production and seeing what outcomes you get. But usually you do that once you're happy on this, the fast evals that it seems like things are mostly working. Okay, and then finally you need to deploy it. There's, at this point, the ecosystem is actually quite mature here. Of course, we do this at OpenPipe. There's lots of different hosting providers for inference that you can just upload your weights to, and they'll take it from there and give you a nice endpoint. Sometimes they'll even do auto scaling for you. We do that. And you can also run it yourself. So you can run with VLLM. There's actually, you can even run it on CPU, like with llama.cpp and Ollama, tools like that. So this ecosystem is actually quite mature at this point, and there's lots of good guides out there. Okay, so that's it. I've got 4 minutes left, and anyway, this is kind of just to go back to the why. The reason why is you get much better quality at a given point. And that's it. So yeah, happy to take questions.
Awesome, thank you, Kyle. Any questions in the room? I can run you down a mic. If you want to raise your hand and stand up, I'm sure everybody wants your codes first. Great.
Okay. Yeah, it looks like way in the back.
Hey, hello, Mario Vinasco, University of Phoenix. Great presentation, great insights. I didn't know some of those tricks that you just talked about, but I'm curious when you say that you fine-tune with the quality output of the mix of experts, what is specifically, what outputs do you feed and what layers do you freeze and unfreeze? Can you go more specifics into how you fine-tune based on that quality output?
Yeah, totally fair question. So let's see, the outputs we use, so this is somewhat task dependent. That said, we have found that like these very basic prompt chains, like the mixture of agents that I mentioned, are actually pretty general. And so for like 80% of our users, they can just apply that and relabel using that, and then they get good quality. You asked about some like very technical specifics, like which layers do we freeze and unfreeze. So with OpenPipe specifically, I mean, basically you have full flexibility here if you're doing this with open source. With OpenPipe specifically, we will target all of the linear layers, and we do what's called a LoRa fine tuning. So basically we freeze all of the layers, and then we insert our own adapters on top of all of the linear layers within the model, which are much lower rank. They're relatively small matrices, and we tune those. This is a fairly well understood industry technique. The advantage of doing it that way, as opposed to training all of the weights, is mostly at deployment time. You end up with basically much more efficient deployment. So instead of having to like slug around these, 16 plus gigabyte artifacts, which are like the full weights, we just have these very small, like 40 megabyte adapters, which means we can run them really fast, have 12 of them loaded on the GPU at the same time, running batches in parallel with 12 different models, and then swap them in and out in fractions of a second. All of that said, one thing I would emphasize is that we have done a lot of different studies and ablations on the actual fine-tuning techniques. We have found that for 90% of use cases, the differences are very marginal. Even switching different base models, the differences are relatively marginal as long as you stick with kind of some of the higher quality ones. What makes all the difference in the world is the data quality. Like honestly, that makes a huge difference, and most other things, frankly, mostly don't.
Hi. Hello. Oh, okay. I had a question. You kind of answered it earlier in your talk, which was with MOA. I was going to ask, why not use a lot of smaller models, like fine-tune a lot of smaller models to get better results? And it seems like time and flexibility seem to be the key hurdles there. But I am still curious, are there any real-world examples, of companies that you see use a lot of smaller models, or maybe a collection of smaller models to get their data?
I think so. So this definitely does start getting to use case specifics. I would say in general, the pattern we see is the opposite. To generate the initial data and filter your initial data, you really want to go for the largest model you can afford, because all else being equal, it's going to be stronger. And then you distill that down as part of the training into the smallest model that can get you the results that you need. I don't think there's much advantage to trying to minimize the size of the model for sort of the initial data generation and filtering.
Amazing, guys. Any other questions? Yes, great. Let me run your mic.
Thank you. So after you apply MOA to Claude Sonnet, for example, then you're using it to fine-tune only the smaller models. Is there a reason that you wouldn't include a fine-tune of Claude 3.5 Sonnet itself in the Pareto frontier?
Yeah, because currently Anthropic does not allow you to fine-tune Claude 3.5 Sonnet publicly. Otherwise, yes, we absolutely would.
Okay, that makes sense. Thank you.
One more here.
Thank you for the presentation. I just wanted to know, how does fine-tuning make it faster? It makes sense that it's cost-effective and it becomes reliable, but how does it become faster?
Yeah, so what makes it faster is moving to a smaller model. So even without fine-tuning, Llama 3.18b is already much faster than GPT-4 Turbo, just inherently. The problem is you're training off quality. So what it does is it lets you, for a given model size, get higher quality, and then you can trade off some of that quality basically by moving to a smaller model size, because you're able to recover so much through fine-tuning, if that makes sense.
Excellent. I think we have one more question. If you want to pass the mic back, it will be our last question.
Hi. I'm not sure if this related to the topic, but I'm trying to understand things. Basically, in order to get a higher quality, we do fine tuning, but there is something called RAG as well, and I think in the model itself, I can overtrain it. I'm not sure if they call it grokking or something. So between these three methods, what is the optimal for the quality and let's say even the pricing when I deploy it?
Yeah, okay, so you mentioned RAG as another technique. RAG is basically pulling relevant context into your context window, like at the time you're running inference. We find that like for the purposes of gaining new information, RAG makes a ton of sense. And it can also work to some degree as a way of pulling in context examples of doing the task. It's not as good at basically like teaching the model the shape of its output or the feel of its output, you know, like the type of tone it should use, the type of words it should use. Those kind of things don't really come well through RAG. But as far as like the specific information it should use in generating an output, you can use RAG for that. So in practice, we find a lot of people use them in a complementary way. They'll use both because they help with different aspects.
Brilliant. Thank you so much, Kyle. So let's give it up for Kyle. Come on, guys. Great. Next, we are going to hear from Anushrut, who's going to be talking to you about the future of RAG is data singularity. We'll just take a couple of moments to get set up. We'll be on our way.
Two laptops. There you go. All right, good evening. How are you all tonight? Good. I'm Anushrut. I'm a product manager with Hasura, building this new thing called Pacha, which is essentially a new paradigm of building truly useful LLM applications which can connect to your real-time data sources. They can take action, have access control, and are truly intelligent. So let's start with a few questions. Who here has tried building some AI application? Half of the people here, more than half of the people here. What kinds of data sources are you connecting to? Let's start with vector databases. All right. Structured databases, SQL databases. I'm assuming you're doing text to SQL, right? Is there anything else that you do? Anyone trying a new approach? Okay, text to SQL. NoSQL databases, MongoDB, things like those. All right. Again, I'm assuming you're generating the queries, right? All right. So in this talk, I will show you what's fundamentally missing about building truly useful AI applications. Why a programmatic runtime is key. Why a structured memory is important for LLMs. And why we need a unified query layer across any kind of data source. Let's start with this example. Has everyone seen this? Asking ChatGPT how many R characters are there in the word strawberry. If you ask ChatGPT this, it says 2, which is not true, right? Now, if I ask it to do the same by writing code, which is write a Python code to count the number of R characters in strawberry. It'll write the Python code and give the right answer, which is 3. So LLMs fundamentally behave like humans. And if you, let's say, sir, what's your name? Nikhil. Hey, Nikhil. If I ask you how many E's are in this sentence, what's the answer? You have to count. How will you count? You'll run the sentence in your head again, try to see where the E's are, and then give me the answer, right? So that's pretty much how humans also behave. We write this mental program in our head, try to answer as many questions as we can. Now let's scale it up. If I ask it to ask ChatGPT to sum up 1,000 numbers, it can't do that. It'll give me a random answer. But if it could write a program which could sum up those 1,000 numbers, it'll give me the right answer. So let's take a real use case. So which is we at Hustler, we are an enterprise company, enterprise software company. So we have a bunch of customers ranging from big companies to even individual developers. And there are a bunch of customer support tickets that get raised. And we wanted to create a smart assistant for our customer support agents, which would connect to the Zendesk data, which has all the tickets about our customers, which has, we have our billing and invoice data in Postgres. We have the product usage data. Right now we have it in Postgres, but we pull it from BigQuery. And with all of this data, we want to give the ability for our agents to get the right information when they need it, do any analytics they need to do, and even take action all through an assistant, a chatbot. So first we try to do it using function calling. Tool calling, I'm assuming everyone has heard of this term, tool calling, which is basically asking your LLMs to figure out what, you give a bunch of functions to your LLM, ask you to figure out what is the right function to, which can take action, and then it, which is usually an API, which your LLM can hit and get some response back. But we asked it a very simple, we implemented this using function calling and asked it a very simple question. How many tickets were created in the last 30 days? The actual answer was 78. It responded with 65. Why? Because there was no count function in our Zendesk API. It was just fetch the tickets from our Zendesk API. So it tried to fetch all the tickets and all the open tickets and then count them. In the context, there were 75 or 78, whatever, tickets in the context. It could not count how many there were. As simple as it couldn't count how many hours were in Strawberry. So similarly, we asked it, show me all the open tickets from last week in a table. Okay, so roughly 7-8 tickets from the last week. Show me all the details about those tickets in a table. It fetched all those tickets, fine. But when it tried to create this table, it forgot what exact words were there, right? It was just trying to guess it, because it was still hallucinating, right? Because it can't one-to-one copy the structured response that it gets from a function into a table and export it out. Because it can't really understand how many entities are in a JSON list, what exactly the key value pairs were in the JSON list, what was the exact text in a specific key value pair. So now we asked it to do another thing, which is for these latest 50 tickets, can you fetch all the comments on these tickets and give us a summary? That's it. It went off the rails. How does it loop across 50 tickets? How does it fetch, hit the fetch comments function for each of these 50 tickets? It can't do that. So that's why what needs to happen is LLMs need to have the ability to write and execute code and consume this tool output directly instead of dealing with data from context. And since tool outputs have to have a schema, have to have a structure, and these LLMs should be able to write code to fetch essentially hit these tools and be able to understand these structured outputs from these tools. So which is why you need these things called what we're trying to call it cognitive programs. So once you give LLMs the ability to write and execute code, and so now, and also give the LLMs ability to use the data that you have received from a function output, not in context, not in memory, but save it somewhere as structured memory and retrieve it on demand when required. All of this I'm going to show you in a demo. I'm trying to do a live demo. Let's see if it works. So now, if I can just preserve the structure and fetch it whenever it's required, there will be no memory loss. There'll be no context loss. Also, if you could define a consistency across any kind of data source, let's say, for example, if some function takes timestamp as a Unix epoch, or some other takes it as a ISO 8601 timestamp, there is inconsistency, right? LLM might get confused what kind of input do I want to give, or might get confused to understand what the output was. Or maybe, let's say, some function takes a list of arguments to filter versus some other function takes a filter expression. Why this inconsistency, right? So you're making the job more difficult for the LLM to generate these inputs. So if there was a structured query language to do all of this, and there is called SQL. So if I can represent everything as a SQL query, be it, of course, SQL database call, a NoSQL database call, a vector DB call, or a API call, if I'm able to represent all of these as a SQL query and define a SQL query layer which can translate a SQL query into whatever the specific data source takes, I can have this, and LLMs are incredible at generating SQL, right? So I can have this unified query layer for my LLM across all data sources. So why don't I show you a demo and all of this in action? So just same example, which is, this is my chatbot which I quickly put together with a very crummy UI, but it has Zendesk connected to it and Postgres connected to it. And let's say I have these queries here. Let's say if I pick this one, which is, can you see this? Can you all see this? All right. Which are our top 5 projects based on number of requests? So Hasura is a cloud product. We have a cloud product, and we have projects hosted on that, and our users can use the Hasura API in their own front-end applications, and we get a bunch of requests through our cloud. So I just want to see who are which are the 5 biggest projects on the Hasura cloud. Now, this data is stored in Postgres. Actually, I should just run it because it's going to take some time. So this data is stored in Postgres, where we have data about all the requests about all the projects and how many requests they have received. Now, to fetch this data, first of all, the LLM is trying to write a Python code, which will essentially hit the Postgres connector and fetch all the projects and sort them by in the ascending and descending order, and then limit it to 5. That's what it's trying to do. Let me just make sure it's working. Yeah, it's working. This is a big query, so this is going to take some time. As it runs, I can just show you here. I just ran the same thing a while back. So basically what it did was write a Python program with SQL embedded in it. This SQL hits the SQL layer, which translates this into the Postgres query, which fetches the data, gives it back to the LLM. It generates the output, stores it in an artifact. You can see the artifact here. It's my crummy UI. Yeah. Stores it in an artifact and shows you these are the projects, these are the number of requests that these projects have received till date. So actually, this also worked perfect. So now if I ask a follow-up question, are there any support tickets for these users? So now this is an interesting query, right? Because first, it has to join the data from my Postgres table to my Zendesk ticket data, right? And then also remember what were the customer IDs for these projects, and then fetch those specific tickets from Zendesk. Function calling, I don't think it can do it. But okay, are there any support tickets for these users? While we let it run, I'm just going to show you the same thing here. Are there any support tickets for these users? So first thing it's trying to do is try to get the email IDs for the users, right? Get the user details. So who is the owner of each of these projects? It's trying to figure that out. So first it hits the Postgres. You see this here, executed a get artifact. So this is the memory that I'm talking about, which is if I store all the user requests, all the project details which I fetched in the previous query and store it in an artifact. Next time I run an LM query, if it thinks it's relevant for itself, it can fetch the stored memory in the Python program. So that's what it did. Figured out who were the project owners for each of these projects. You can see the data here. I'm so sorry I'm horrible at HTML. Okay, so this is the data it figured out, and now for each of these owners that it figured out, now it can consequentially run another Python program to fetch the Zendesk tickets. And that's exactly what it did here as well when you run the program. So now it has all the support tickets for these 5 top users. So these 5 top users have 9, 13, 6, 12, and 17 tickets, it told me. Gave me a nice summary, put all the tickets in an artifact, and stored for itself. You can check out the artifact yourself. Horrible UX. These are all the tickets. You can see the data, but as well as it has saved it for itself in case it needs to refer to it again in the next query, which it will. Because now I'm going to ask it, for all the tickets from the owner of the first project, I'm not telling which project, the first project, summarize the contents and comments of each ticket and use those summaries to classify each ticket as not important, somewhat important, or very important. Extremely complicated query. Let's see if that can work. So while it's working, I'll show you here. I asked the same query here. Now what it'll do is, it will again refer to the artifact, get all the project owners, get all the tickets, and then what it'll do is, it'll fetch the ticket data as well as the comments on those tickets for the specific user I'm talking about, the first user I was talking about. And then what it'll do is, it will call another LLM. We have defined 2 LLM primitives. One is summarize, the other is classify. So it will call the summarize primitive to summarize each of these tickets, which you can see right here. So it's basically summarizing each of these tickets and then using those summaries to basically classify each of these tickets as not important, somewhat important, or very important. And then it gives me the output of this again as another table, which is come on, not this, sorry. Yeah. So, which is again classified based on the ticket, based on the data of the ticket, based on the content of the ticket, comments on the ticket. Very important or somewhat important. So, which happened here as well, perfect. And now, this is the coolest part. Now, let's say I realize that the first ticket, I need to reimburse the user, let's say with 20 Hasura credits. So if I ask it, issue 20 credits to this project, it already knows which project I'm talking about. And if I just do that, let's see. This time I won't switch to the first tab. All right. So it's trying to execute this Python code. But now, here it's creating an action, it's doing an action which creates a permanent change, right? Which is raising the refund or the issue or the credits. So it asks me whether I'm sure I want to do this or not. It tells me exactly the query it's going to run, which is going to make this mutation. So if I approve, let's say I approve, then it can go and take that action. It will hit the right API to take that action. There you go. It issued the $20 credit to this specific user and took action. So that's what happens when you give an LLM a programmatic runtime. If it makes an error, it can heal itself. If you define this unified query layer, which is SQL, which works on the Zendesk API, on Postgres, or any other kind of data source you have, which has structured memory in it so that it can refer to that memory whenever it needs, and there is no context loss, there is no hallucination because everything has been stored. And then you can always, because you have this single query layer, you can define all the OGSI rules on it. So that is the Pacha approach, the new paradigm that we are thinking about. If you want to learn more, you can always go to askpacha.ai, or you can reach out to me. And if you want to set up some time with our dev team, would be happy to do that as well. And yeah, that's been Pacha and LLMs.
Awesome, guys. Any questions?
Any questions?
Great. Yeah. Okay, let me run you mic.
Thanks for the talk. It sounds to me stuff that you're trying to accomplish here can also be done through agentic LLMs. How do you see this agents? Where's the differentiator here?
Yeah.
Are you trying to fundamentally go in different approach? Thanks.
Yeah. So with agentic LLMs, you still are, you were still doing at the end of the day function calling, right? Which is an agent to be able to talk to a specific data source. It has to call a specific function, which will fetch the data, give it back to you. The problem of this response being structured, but LLM's understanding being unstructured, and then passing context from one agent to the other also being in text, right? Is where you have scope for memory loss, is where you have scope for hallucination, right? And is not really possible if you have thousands of entities in your data that you're trying to work with. If you want to do analytical queries, let's say, you want to generate reports, you want to generate visualizations, you want to fetch data from 5 different data sources, do joins on them, and then get some coherent output.
But you could potentially do that with multi-agents too, right? With different agents doing different things.
And how would that solve for the memory loss issue?
What memory loss are we talking about here?
No, so to pass context from one agent to the other, right? It has to go through an LLM, right?
Right.
Yeah. So if the context is huge, massive, thousands of rows of data, how does that happen?
So you're saying you're trying to move to structured memory or data structures to address that problem. Is that the problem
Correct. So
statement?
that's one piece of the puzzle, yeah.
Gotcha.
Yeah.
Okay.
Any other questions, guys? Yeah.
Hi. So I've kind of balked at the SQL approach because I couldn't think of a good way to make these queries run quickly. So I was wondering, in your first example, which I don't think it didn't like interleave, like for instance, a bunch of summaries per call, just the SQL part. What do you think is the fastest you could get that? And what would you advise a team to do?
So the first call that you're talking about?
Yeah, just as an example, because
Okay.
it's really complicated, right?
Yeah. So with SQL, the thing is, this SQL isn't directly being executed anywhere, right? Because this SQL is a representation of the request that you want, right? The data that you want. This SQL layer that we're talking about, what it does, it deterministically translates the SQL into the native query language of that database. You can ask me, how would you represent, let's say, an API call, right? Like, let's say, for example, if I show you this, I have, like, yeah, a simple API call, which is get the weather in New York City. I can represent the same thing as a SQL, which you see here, and all I have to define is configure my API connector in this SQL layer, and just this translation happens in the SQL layer. So this SQL itself is not being executed. It really just depends on the processing time of your data source.
Thank you. Anybody else? I was going to say, don't be shy, guys. If there's anybody else, last questions. Okay, brilliant. Well, thank you so much.
Right?
We're going to
Thank you
pass
so
over.
much. If you want to reach out, please feel free to do that and scan this QR code, and we can help you set up some time with our team. We'd love to riff some ideas with you and just get some feedback on this approach in general. Thank you so much.
Great. Thank you. I was going to say, next up, we are going to be hearing from Justin from Helicone. We'll just take a couple of moments to get it set up. I think they have some fun things planned.
Actually, just give me 1 second. Let me just go like this. Sorry. Let me just make sure all my tabs are set up here. Okay.
Are we good to go?
I think we're good. Hello. Hello, everybody. Thank you so much. Perfect. Awesome. Thank you so much, everybody, for showing up. It's exciting. All right. So, hi, my name is Justin. I'm with Helicone, and I'm going to be talking to you about building AI applications that actually work, in quotes, because, you know, it's very buggy these days. If you guys want to connect with me, feel free. I just put like my link tree up there. Yeah. All right, so quick background. Hi, I'm Justin. I'm a software developer by trade. I left software developer like IC role to start a company called Helicone. Helicone is an open source observability tool for language models. So you've been hearing about LLMs all night, and you're going to keep hearing about them for a little bit longer. So quick intro to Helicone. Helicone is a really easy way for developers to get started logging with their LLM applications. It's just 2 lines of code, and then instantaneously you get amazing dashboards that kind of get populated with all of your data. If you want to look at Helicone's metrics, you can go to helicone.ai open-stats. And so far we serve over 100 SaaS companies on our cloud product, or sorry, 1,000 SaaS companies on our cloud product. We have over 10,000 SaaS users. Helicone right now is processing over 20,000 messages a minute. And we've logged over 1.7 billion LLM calls. That's roughly like 20 million people may or may not have used Helicone, like, or don't know about it, like don't know that they've used Helicone. And you know, doing Helicone and servicing so many other customers, we always see a ton of questions come up. Like people ask us, what model should we pick? Should we use a RAG framework? What tools should we use? Or should we even use tools like LangChain, evals? Is any of this AI stuff real? And some of them just cut straight to the point and ask, can you please just tell me what LLM stack to use? So I feel like there's so many tools out there, and it reminds me a lot of this sort of code complexity curve that's very popular in software engineering, where you have super simple code that you kind of start out with, and then as you start learning more design patterns and like abstractions, it starts blowing up in complexity, and then after a while, it's just super simple. I think we're kind of in this like learning curve together as like a society using language models, where kind of just prompting's on the left side, you use a bunch of tooling in the middle, and then hopefully I think we'll get to this point where we're just all gonna just be prompting the models. But right now we're not there. It doesn't work, so we can't just do prompting. It's a little bit too early, the context windows are too small, there's a bunch of quality issues, you wanna do agent flows like we saw in the last talk, and occasionally you get responses like this, where I don't know if you guys seen this one, but it says cheese won't stick to pizza. You know, just eat glue is what Google responded with. But yeah, so how do we actually fix this issue? The landscape right now is extremely complex. There's lots of choices developers and teams need to make. One, they need to pick like the model provider. They need to add some sort of prompting layer. They'll usually want to add a gateway to manage all their users and requests coming in, maybe an LLM load balancer, an agent framework, fine-tuning service, shout out to OpenPipe, wherever Kyle is, maybe a RAG framework, retrieval service, all the stuff, eval tools, even more. And then you end up like with a stack that looks like this. You get like a bunch of services almost. So I feel like we're a startup and we are selling to a lot of startups, and they're always looking for this 90-10 solution. They are constantly being told, do things that don't scale, don't rewrite your backend. And I like to rephrase it as, rather than like do things that don't scale, do things that scale just enough. So keep iterating through your product and keep adding services just for whatever you need to do. You don't need to make it too complicated. So I'm actually going to be walking through in like a full coding example. We're going to be coding, and hopefully the demo gods are with us today. We're going to be making an email assistant, which is like hopefully to show you how complex these systems can get from just a small inception point. So how do we start from just querying the LLM to ending up with something like this? And we have 30 minutes to do it. So this is gonna be exciting. So in the basic case, we have a client that calls an LLM provider, and I have a fun demo for you guys. Give me 1 second here. All right, so let me just make sure I do this here. All right, so here, welcome to our new startup pivot. It's Helicon Emailer. I'm kidding, we're not actually pivoting. But it is a email summarizer. You're gonna have, let's imagine we have a bunch of emails and we want to write a summary for these emails. So here's a bunch of emails. You can click this summarize emails. We have no loading screen because I built this last night at like 11 p.m. And then once this runs, it's going to go ahead and take all those emails and dump that summary. It's equivalent to just like copy and pasting it into ChatGPT and using that prompt. And let's go ahead and see what this code actually looks like. So if we look at the code, it's literally taking in, here, hopefully you guys can see that. No, okay. We take all the emails and we literally just ask ChatGPT, hey, can you summarize the following emails? And then just take the content and we're just dumping it back into the UI. There's really nothing magical going on here. It's super simple. So the next piece that we usually see, and this is kind of where Helicon came about, was when we talked with enterprises and startups, the first thing that people built was some sort of observability layer. So I'm going to go ahead and kind of add Helicon as our observability layer into this application. So I kind of cheated a little bit, and I already have like little branches here that have everything built out. But to add Helicon, all you do is you just add this base URL like that, and then you just add this one line of code to provide the Helicon auth. Now, if I go to our Helicon dashboard, which will go right here, and that will sign in just a second, maybe not. Okay, and then I created this org for AI for developers. And now if we go and look at our requests, these are like old requests, but now if I run this same example, and it's over here on this tab. Now if I run summarize emails, it's gonna run the exact same code, but in Helicon, what we're gonna see is we're gonna see that request come in just a second once our logging catches up. Hopefully. Okay, so now we just saw a request come in, and basically we get like a full summary of what our user is doing. So we have like basically a full chat completion request, and then we have like full dashboards. And the next thing that we see users do is they end up adding more telemetry. So they'll add like environments. They'll want to track their own users. So here I just put in my email, and then their app is still running. So like our summarizer email still is like kicking off in the back end. And Helicon tracks all this stuff. So we track all of your user data. We'll track like the actual requests that are coming through, with like tagging. So if we wanted to see the environment, this will be tagged. And then, so this is sort of the second part, which is the observability. We can get cost tracking, user metrics, look at the completions, and most importantly, like be able to experiment with those completions with the playground, which I'll show in the next part. But once you kind of have this like first layer of, hey, now I have some observability layer, I have some client talking to an LLM provider, now you're like, you want to start scaling up this application, whether or not it's like in the Hasura demo where you want to call a Postgres database or some vector database. You want to have basically like this external service that you're populating this context with. So in our emailer case, we might have like hundreds of emails or thousands of emails that we can't just copy and paste to ChatGPT. So we'll go ahead and embed all of those emails, and we'll like chunk them, and then we'll like retrieve the most valuable ones to go ahead and put it into our context. I didn't build this out last night, but I'm just going to kind of pretend like that exists for the demo's sake. The next part that we see users want in their LLM applications is this gateway. So they'll want some level of security or caching or rate limiting or cost limiting. And we've built a lot of these features directly in Helicon, but there's a lot of other tools out there that kind of help you with security. So I'm going to show you how to add that in Helicon really easily. We take advantage of this thing called headers. Or like these this like header fields. Let me go like this, sorry. So here you can see like the Helicon, it's like super easy to enable cache. And once I make a request to our email summarizer, the first request is going to take a second while this kind of gets loaded in. And then if I make a second request, it's going to be instant because it is going to hit our cache. So you can see that was like super fast, hit our cache, and now you can like improve the speed of your app and whatnot. Yeah. So I'm going to show you guys one more thing as well that folks tend to do. The next piece that I want to show off is our rate limiter. So if you are using an app, and I'm sure you guys are building apps or you guys are working for a company that is using LLMs, and you want to be able to like rate limit on cost, this is one of the biggest things that we see is like a user will go in and be using some LLM app, and they are getting like hammered from one like free user, and then their cost is just going up a bunch. You can add like rate limit policies directly into Helicon, and that also will get rate limited. So this kind of all ties into the gateway. The first like gateway and observability pieces are mainly what Helicon was built for, and like why we built Helicon. The next layer we typically see is prompting, where users want to be able to track the inputs and outputs and generate some data sets with this like prompting layer. It's really helpful, especially in the fine-tuning side of things, like those generating data sets and then creating those JSON-Ls, kicking off a fine-tuning job. And we also provide this in Helicon as well, which is like this prompt management library. So if we go over to, let's go to step 4 here. You can see here our email app is about to get a major upgrade. Here we have this like crazy prompt. This is a prompting technique called few-shot prompting. I don't know if you guys have heard of few-shot prompting. It's this idea that you can provide some examples and then some outputs. And this is a classic prompt where it's just going to say, hey, I want you to summarize the emails that look something like this. And now we have like this prompt with the inputs, and then we have HPF, which is this like Helicon prompt formatter. And if we go ahead and rerun our summarizer, you'll see now the output looks a lot crisper. Maybe some new lines were added. You can actually see, hey, we have the key points, and we have others. So it's kind of formatting it the way that we want to, because now we added this prompting layer. And in Helicon, if you want to view that prompting layer, you can. So you could go over to prompts, and you can hopefully get a better view of what it looks like here. So you can see like, hey, please categorize the following emails into one of the categories, email content, input, and then we get like some output. And this is like the categorizer. I think we have a few prompts that we're getting kicked off here. We have this like summarizer one. Like here are a few examples. Please summarize the following emails, inputs, and then you have your output here. Cool. Nice. So I'm going to keep going through these slides here, and we're doing OK on time. Nice. The next piece that we see, like the next evolution in this AI stack is agents. So once you have this prompting layer, once you have this gateway, you have like a bunch of RAG stuff, we see people start adopting these like agentic workflows. And this is, again, you saw this in the last demo for Hasura, where you create some requests and then it calls something, takes that output, puts it in the LLM. Maybe the LLM is deciding what to do with that output and then feeds that output back into the LLM. So it's usually some sort of loop basis, like some orchestration layer. And we built this also in our email layer over here. So let me go ahead and show you what that looks like. So get checkout step 5. It looks like there's some changes here. That's fine. Cool. So here now we have a new, some new logic added to our emailer. The main idea here is we want to, sorry, yes, okay. Give me one quick second here. I think I maybe switched up these roles a little bit. Sorry about that. The demo gods are not with me today. That's okay. Okay, perfect. Yeah, I don't know what was going on there before. Okay, I'm gonna hold off on this part of the demo, but I'll show you what it's supposed to do. The main idea is that you want to take this like sort of like agentic workflow of saying, hey, I want to have multiple LLMs being called and at some time and then perform some actions on it. So this is what it looks like, sort of like this emailer example, for example. If we wanted to take each one of those emails and categorize that, so we wanted to use like a lower model to categorize those emails and then bucket them, and then with each of those categories, then kind of like create a summary for either work, personal, or other. You can, like, this is basically this whole flow, and this is it like kind of visualized. So in here, right where I'm kind of hovering my mouse, this is categorizing multiple emails and then taking those email outputs and then running a call right here to say, hey, here are all of these emails. I want you to write a summary based on the ones that fall in the other category, the ones that fall in the personal category, the ones that fall in the work category. And this is basically like a tree view. Hopefully this is making sense. I'm realizing it's like maybe a little bit complicated here. Cool. Yeah, so right now our app is getting pretty complex. Like we've already gone so far where we had our basic like email retriever that would like send an email and then, or no, sorry, it would look at an email that was sent and it would give us a summary on it. And now we've like built out a whole flow where we have like some RAG pipeline, we're doing some prompting, we have like an agent flow that is like pulling in a bunch of data and like kind of categorizing things before it like summarizes it. Now it can even get more complex where you can add like a model load balancer. So in some cases where you have fine-tuned models or you want to decide what model is the correct model to call, there's a new startup that just kind of launched called Not Diamond, if you guys heard about it, but it lets you sort of intelligently determine which model is best to be used for this particular use case. If you want to optimize on cost or quality, these types of things. And then it can even get more convoluted where you have experimentation. And this is where I think tools like OpenPipe or tools like Helicon kind of shine, where you can test your prompts, generate golden data sets, and build these data sets to be used for either fine-tuning or evals and whatnot. And I can show you guys what that looks like in Helicon, but I know we're running a little bit low on time here. So if I have a prompt here, let's say I have this like categorized email prompt where we have some email content and we want to give it a category. So in this case, we have a bunch of inputs where you say, okay, here's some email. What was the output? This one was work. This one was other. This one's also work. If I want to start an experiment to say, hey, if I have this emailer and I want it to like always respond, like if you notice here, this is lowercase here, I can like add an extra instruction to say, always respond with lowercase. And then I can save that, run this, there's that demo there. And then I can go ahead and generate a random data set. And then I can grab a key, which I am going to grab a key from here, and I'm going to have to cycle these immediately because people are seeing these keys. That's okay. Don't mind that. So we grab this key, we use this provider key, confirm and run this experiment, and it's going to go ahead and basically change the model or change the underlying prompt and use all of those new prompt with all the previous inputs to run this experiment. So you can see this experiment's running right here. It's going to take a couple minutes for that to continue. So I'm going to go back to the slides and continue through them. Let's go here. All right, so I would say and then the last part of this like stack, which I think Kyle hit it on the nose perfectly, which is like, once you feel those like real pains of, hey, I'm running into a wall of like cost, quality, or whatnot, I want to do fine tuning, and fine tuning is great for the last mile, and will provide a bunch of support on these like tailored cases. And I knew OpenPipe was coming, so I kind of did like a little heart thing for him. Cool. If you guys want to learn more about what I talked about in this talk, we have a blog post that kind of goes through the stuff. You guys can scan that. It basically just goes through the whole stack, this whole progression that we went through. It's a different example, but same concepts. Cool. And let's see if this experiment finished running here. Looks like it's still running, but I think we can still view some of the outputs here. All right, so we wanted to respond with lowercase. We added that extra instruction, and it looks like it's doing that here. So you can see here are the previous outputs with the old changes. So we didn't have that instruction, always respond with lowercase, and it looks like it's responding with lowercase in the newer ones. So we can go ahead and mark these requests as successful. And that's kind of how to build an app from scratch using Helicon as well. I think the last few things I want to leave you guys with is try to keep your LLM stack slim, and try to do things that just scale enough. Like, you don't want to build I think a lot of our customers look at all the tools that are out there, and then they end up building this like complex flow. And I think like a lot of the times you don't always need this like crazy stack. You can probably get away, hopefully one day we'll get away with just prompting, but I think we're still like maybe like 5 years out from that. Cool. And last thing is we're doing our product hunt launch tomorrow. So if you guys have a product hunt account, we'd really appreciate upvotes on our product hunt, or like clicking the like get notified thing. So that's it from me. Thank you so much for listening to me talk at you for 25 minutes. Appreciate it.
Cool. Thank you, Justin. Anybody got any questions? You can raise your hand. I know there's some people still trying to get your code. Good timing. Anybody there? You raise your hand high for me. Please don't be shy. It's a really good opportunity.
I think everyone's just tired.
Okay, cool. Let me get you mic.
Thanks for that talk. I'll give you an opportunity to sell a bit more. So, like, what is the free tier of the product, and how would you compare some of the competitors in LLM observability? Like, why would we choose this product?
Yeah, so Helicon's free tier is really generous. It's 100,000 requests, and it's mainly built for scale. Like, I think the like as far as compared to other products, like we have service like we have served like billions of requests, and a lot of our dashboards and stuff are extremely fast, and we're very developer focused. A lot of the other tools on the market are like geared toward PMs, I would say, whereas we are trying to be developer first, and we're open source. Yeah.
Here. Cool. If you just want to stand up here.
Yeah, cool demo. Thank you for walking us through that. So I noticed, so I see the observability and traceability of prompts, and that's really awesome. But I wanted a little more information about the testing of prompts. So is that something like that? Would we enter the like A/B split test into your interface, or is that like a newer feature, or kind of are you going in that direction of additional features? Just for knowledge. Thanks.
Yeah, it's a good question. I mean, we do have, the way it works right now is you would change the prompt and then it would generate like a data set that you can use for that output, either to fine tune or to basically verify that that new prompt is something that you want to go ahead and push into production. All of your prompts would live in your code, so you don't actually have to change it in the interface. You would just change it directly in your code base. Yeah.
Great. Anybody else there? Yeah, there's another. Oh, sorry, I can't see your hand down there. Great. If you want to stand up.
Hi, thank you for the talk. I had a question regarding fine-tuning. When you're recommending fine-tuning for tailored cases, what are some of the techniques that you use, and how do you solve, or like how do you take precautionary measures to not run into issues like catastrophic forgetting?
Yeah, so I'm not an expert in fine tuning, so I would probably like consult someone else on this. But what we typically see, kind of like echoing what we heard in the first talk, is data sets are extremely important. So generating that golden data set to understand, hey, this is my use case, and I want to make sure that it aligns with this golden data set is extremely important. So I would say like focus on that data set curation and make sure you're always testing and monitoring it, because typically we can see like fine tuning ends up like overcorrecting, and a lot of our, like a handful of our users end up fine tuning and then end up like not sticking with it. Because like the new model comes out, so like they'll fine tune like a Llama like 7B or something like that, and then a new model will come out, and then that new model is like GPT-4o. We saw a lot of people move off of their fine-tuning models because GPT-4o came out, and it was like pretty good. Yeah.
Thank you.
Yeah, of course.
Hi. When you talk about observability and metrics and quality is great, but if you open the hood of these LLM models, what we find is a very rich analytical representation of context, right? Whatever you feed, it gets translated into numbers, vectors, embeddings,
Right.
things like that. I'm very interested in exploring that, how I can leverage it. How can I open that hood and see those numbers, explore what's similar, what's opposite, what's 90 degrees opposite, right? If you want to talk about recommendation systems or customers or whatever it is, I would be very interested to do that. Can your tool do that? Are you guys thinking about that?
Yeah.
Opening that hood and leveraging those numbers? Because if you look at the numbers, they don't make sense, right? Completely abstract. They need some structure. I would love a tool that can help me do that.
Yeah, I think, so just to like reiterate, we see this a lot, where customers want to take their LLM chat completions and they want to say, hey, all these chat completions exist in some semantic space, right? Like if you think about it, it's like this 3D map of all these different ideas where you have maybe like something that is more like feminine sounding or something that's more masculine sounding, and you can like kind of see these like different vectors. There's always some sort of like vectors where it's leaning between 2 points. So there are a bunch of different tools to do this where if you like vector them, you can do like clustering. So to answer your question, no, it doesn't exist in Helicon yet, but it's something we are definitely looking at, where we want to be able to take all these completion results and cluster them within ideas, and then say, hey, we found all of these clustered ideas, and then like pull them apart, say, okay, this exists, like this is more chicken and this is more frog, or whatever your 2 points that you're trying to look at. There are a lot of tools out here that kind of look at this. Actually, Neo4j, if you guys went to their desk, they actually had a little demo of this like semantic graph there. And a lot of people are looking at this. There's a lot of open source projects that are looking at doing exactly this.
Great, thanks. I have one more question down the back here, if you want to.
Thank you for the demo. That was awesome. Quick question, just asking about speed. Does the observability layer affect speed in any way?
Yeah, so it does affect speed, but like very minor compared to the actual completion of the model. Because for completion of a model, even using Grok, something like that, we're looking at like hundreds of milliseconds possibly. Whereas the only delay that you have is like the propagation delay to wherever our proxy is distributed, which is on all the edge nodes. So it's like at max, like we only ever measure like 10 millisecond delay, which is nothing typically.
Thank you.
Yeah.
Brilliant, thank you so much. Are there any final bits and pieces? If not, thank you so much, Justin. That's been brilliant. Oh, you have a question here?
Yeah, please, by all means. Hi, thank you for your talk. My question is just sort of general around your semantic graphics and RAG, and I'm curious to know how you're using RAG in your fine-tuning.
So the question is around semantic graphics and how we use RAG in fine-tuning? Or how to use RAG in fine-tuning?
Is this something that's built into your system already, or it's...
No, it's not.
Are you using a separate agent, excuse me, not a separate agent, but a separate tool for that? Or
Yeah. So there's a handful of open source tools to do this, where you can like export data from an observability platform, and then you can export data from that observability platform, and then load those into any of this like semantic clustering things. Like I think there's like some like tensor project that Google put out, I believe. If you just like Google semantic clustering, and then you'll find it. No, it's not. So the question is it necessarily built into Helicon? No, it's not. Oh, no, RAG is not built into Helicon. Yeah. So we can chat after.
Okay, awesome. Thank you so much, Justin. And all of our speakers will be here for networking, so more time for questions then. Great. Give it up for Justin. Come on, guys.
Thank you.
Go on. So if you had enjoyed yourself this evening and you would like to show us a little bit of support, you can find us all across social. We're on Twitter, X, LinkedIn, Instagram. We'd love it if you come back. We'd love it if you share, bring a colleague, bring a friend. You can find us on Meetup and on Luma at the AI user group. Our next event, so we have AI for developers again on September 24th. We have our AI for marketers on September 4th, and we have AI for designers on September 11th. So if you're interested in any of those as well, we would love to see you there. We'll be back in our usual location over at Spaces on 3rd Street. And now I'd love to open it up. So I'm going to share the mic first with Yolande from Neo4j. Just to make a little quick announcement, they've really kindly provided the pizza for this evening. So I want to make sure they get a chance to share with us. And if anybody else wants to come up, please, if you've got a job announcement, you're looking for a co-founder, you're looking for somebody to work with, or you'd just like to introduce yourself, form a little line here, come up, introduce yourself, say hi, tell us what you're up to.
Thank you so much. Thank you for inviting us. So, so I'm from Neo4j. I'm with my colleague Naya, and we have a little space over there. We love to talk to you about RAG, also about, we have a little demo about text to graph. So, but I want to ask, so who knows about Neo4j? Okay. Who has used it in the last 2 years? No? Nobody? Okay. So, because in the last 2 years, we've really changed, and with LLM and so forth. So come and talk to us. We'll tell you more. We love to talk, so.
Speaks for itself. Okay. Make sure you're over at that booth. Down here. Great. You want to stand here for me so we can get you on the live stream? So bigger audience right here.
Hello. Yeah, hi everyone. My name is Ashwini. So just wanted to ask one question. Who have heard of the model Llama 3.1 Storm 8B? Yes, I'm the author of that model that was released 2 days back. And just to make sure everyone knows, that model is the current state of the art in Llama 3.1 8 billion category. And it has outperformed both Llama 3.1 by Meta as well as Hums 3. So give it a try. We have an official post on Twitter, LinkedIn, and yesterday we also launched the model on Ollama. So just give it a try, and the model, based on our feedback from Reddit and Twitter, people are liking it, and in just 2 days, we have seen 6,000 downloads of the model. So, and if you have any feedback to share, just let me know on LinkedIn or Twitter. I think just type Llama 3.1 and I think you will find our post there. So yeah, just give it a try, and yeah, thank you so much. And again, one more thing, like if anyone wants to support our effort in the compute resources, please reach out to us. We are looking for like-minded collaborators there. Thank you.
Hi, everyone. My name is Justin Knoll, and I have a small personal project I've been working on. There's a GitHub repo to apply deep learning to approximating a chess evaluation function. So if you're interested in chess and if you're interested in deep learning, come find me during networking. I'll also mention that next Friday and Saturday, the 31st, I believe, there is a hackathon where Strong Compute is donating a bunch of GPU for anyone that's interested in training chess playing models. I'm planning to participate in that. Hackathon teams are allowed to be as small as 1 person, which is what I have right now, or as large as 3. So if people are interested in just exploring that without committing to the hackathon, I'd love to talk about it. Or if you're interested in trying a hackathon with chess and free GPU, then come find me about that. Thank you.
Awesome, thank you. Anybody else? Any other announcements? I'll just wait a second. Are you coming up? No? All right, okay, brilliant. Well, thank you so much, guys, for your attention. Really, really appreciate it. I want to thank again our sponsors, Neo4j, for the pizza you're just going to have now at networking. And again, a big thank you to our co-organizers, N8N. If you have had a thought about speaking and you would like to get in touch or collaborate in any way with the AI user group, please feel free to reach out to me or come talk to me now. But thank you so much for your attention. Really, really appreciate it.